Are Python object functions singletons? In Java, objects are instantiated with a complete copy of the functions from the class linked to them. This is one of the reasons that the Spring framework has been so successful. Spring helps you cut down on the memory that the Java VM uses if you create many temporary data objects, and other service objects that are served up by Spring as singletons that effectively carry all the functions. I was just wondering if this is true in Python. It seems like it isn't. But that means that if you mess with dict for an object, you are changing all that function for all copies of that class, right? For example, if I create an array of myobj, is there one instantiation of _add_ for each, or just one for all of them?
There is just one instance of the function, which is stored inside the class. The function gets called with a reference to a class instance as the first argument, which is traditionally called self. So, here are three equivalent ways to call the ._add_ method function. Also, in Python, the type signature of a function is not part of the function's name. The only ._add_ method you get is the one you declared. In Python you would simply write your code to make the one function do all the different jobs you might want it to do. For example, if you wanted ._add_ to convert a string into an integer to make x plus 3 return 5, you would do it like so. Note 0. It is best to declare your class as inheriting from object. In Python 3.x, your class will inherit from object whether you declare it this way or not, but in Python 2.x you will get an old-style class unless you declare it with object after the class name. Note 1. We don't bother to check the type of the other argument, we just try to coerce it to an int value. This is duck typing in action. Now not only will a string be coerced to an integer, but anything that can successfully be coerced to an int will work. Sometimes, to make one function do multiple jobs, you may need extra arguments. You can make them optional so that you don't need to specify them every time you call the function. You can read more about this in a Python tutorial. Here's one place, this URL. Finally, in Python, you need to explicitly use myobj.a to refer to that class variable a. If you just use a in a member function, you will get the usual name resolution rules, which will look in the global namespace. The object namespace isn't special. You could also get to a class variable like so. But this will only work if it is a new style class that inherits from object.
Java does not create a new function for each instance. In fact, Java has no function objects to begin with. Python on the other hand has first-class functions. Getting a function object from an instance of a class wraps the class function in a simple object called a bound method. When a bound method is invoked, the underlying class function is called with the instance object as the first argument. You could say that given this object, when you do under the hood this happens. As you can see, for each instance of obj both _func and obj remain the same, the only thing different is the instance used. Try this.
There seem to be a couple of questions here. I'll try to answer paraphrased versions to make it more clear as to what I'm responding to. What sort of overhead is associated with the method attributes on instances compared with classes? In Python, almost all kinds of container, from local variables to class attributes, are references to other objects. When you define a function, the function value is created once and a variable is initialized with a reference to the function. If a function is in the scope of a class definition, Python adds it to the class's attributes, but that's still a reference to the original function. So there's no real way for there to be any overhead to a function above and beyond the cost of references. Furthermore, attributes in a class are associated only indirectly, through the objects _class _attribute, so the number of attributes on a class carries no extra cost on the instances. Can I modify the methods of one instance of a class? Can I modify the methods of all instances? Attributes on an object are in that object's _dict_, as you've already noticed, and this goes for the attributes for a type, which is also an object. When resolving attributes, Python takes a fairly consistent search pattern. First it checks for descriptors in the class, then it checks the instances _dict_, and then the class _dict_. It picks the first of those that it finds. A fairly obvious example might look like so. There's an extra gotcha with methods, though. When you get a class attribute that happens to be a function, Python dynamically turns it into an instance method, which binds the self parameter to the instance, or not, if you took the attribute from the class. This effect only happens when the attribute was taken from the class, not the instance. If you want to modify an instance with a new method, you will have to take care of turning the function into an instance method yourself. You can use types.methodType, but it's my opinion that this case should be handled with functools.partial. Is there one instantiation of _add_ for each, or just one for all of them? It was a long way getting to the actual question, but to summarize, the function for your _add_ method occurs only once. There is a single reference to it in the _dict_ of myobj. There may be many instances of the instance method that wraps that function into a method. In fact, there is one for each time you do the lookup. Python always creates a new one.
If you want to see more, please consider subscribing.